This is lesson 6.5, example 4. The directions here say to describe the possible lengths of the third side of the triangle given the lengths of the other two sides. Our final answer here is going to be a range of values because we don't know if we are finding the middle side, the longest side, or the shortest side. Now this is done using theorem 6.10, the triangle inequality theorem, that states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. What we're going to do here to shorten this up is to pretend two scenarios. The first scenario is to look and see that these two sides here are our smallest sides. So when we add them together, we will see that we have an answer of 18. What that is telling us is if we have any side bigger than 18, our two current sides won't be big enough to overcome them and we won't have a triangle anymore. The other scenario that we're going to pretend is that these two sides are the biggest side and smallest side of our triangles. And what you're really going to do here is subtract these two values. So 13 minus 5 would give us an 8. And what that will tell us then is that the 5 can work with nothing smaller than 8 in order to still be able to overpower or overcome the 13. So our final answer is any value in between 8 and 18. And really that's it. You just simply add the two values you have to find your upper limit, and you subtract your two values to find your lower limit of what the possible values may be. So number 2, as I add these, I get 18 plus 6 to be 24. Again, that will be our upper limit. And then we'll also subtract. So we'll be sure to do 18 minus 6, which there gives us a 12. Now notice the values are less than symbols, not less than or equal to. We can't be 12, we have to be something bigger than 12. That way we can overpower the 18 when we use the 12 and 6 together. Same thing with the 24. We can't be 24 because our 8 and 16 would equal 24, they wouldn't be able to overpower them. Now number 3 is a unique situation. This appears to be maybe an isosceles triangle of some type. We're still going to use our same process. We're going to add these two sides that we have, and that will give us our upper limit. So we can't have anything bigger than 34. And on the bottom of this, or our lower limit, as we subtract, we will get 0. I know it's not possible to have a side length of 0. What that's really telling us is any other side will work. Even something like 0.1 would be just enough to give us a triangle in this case, because it'll help one of those 17s overpower the other 17. And there you have it.